Welcome to our module on backend development, focusing on how to build robust applications using Node, JS and Express. JS. We will explore building scalable and efficient web applications by leveraging these powerful JavaScript technologies. Let's begin by exploring the incredible power and capabilities of Node. JS, a crucial technology for modern backend development. We will see how Node JS unlocks the potential for highly efficient and scalable server-side applications using JavaScript. A core feature of Node JS is its asynchronous and event-driven nature, which is fundamental to its performance. This architecture allows Node JS to manage numerous requests concurrently without pausing, ensuring smooth operation. Node JS utilizes a non-blocking input-output model, which significantly boosts its efficiency when handling data operations. This makes it an excellent choice for real-time applications such as chat applications or live streaming services. Node JS operates on a single-threaded model, which might sound limiting but is quite effective. It achieves high scalability by leveraging its event-driven architecture to efficiently manage many connections. Node JS is also a versatile cross-platform runtime, offering broad compatibility for developers. This means your applications can run smoothly across various operating systems like Windows, Mac OS, and Linux. Furthermore, Node JS enables a full-stack JavaScript approach, simplifying development workflows. This allows you to use a single, unified language for both client-side and server-side development. Let's now examine how Node JS efficiently handles requests using its distinctive event-driven and non-blocking approach. We'll understand the event-driven, non-blocking approach that Node JS employs to process requests efficiently. The process begins with a client request, where a user asks for data from the server through their browser. A user initiates a request for data from the server, typically by interacting with a web page in their browser. Next, the incoming client request is placed into an event queue, waiting for the Node JS event loop to process it. The server then places this incoming request into an event queue, where it awaits processing by the event loop. The single-threaded event loop continuously monitors the event queue, checking for and processing new requests as they arrive. This event loop continuously checks the queue, efficiently processing requests one by one without creating new threads. With non-blocking I/O, Node.js delegates time-consuming tasks to worker threads, allowing it to continue processing other requests. Node.js delegates tasks like database queries to system threads, enabling it to handle other requests concurrently. Finally, once the delegated tasks are complete, callback functions execute to send the appropriate response back to the client. When tasks are finished, associated callback functions execute, compiling and sending the response back to the client. Let's compare the fundamental architectural differences between traditional servers and Node.js. We will specifically look at their multi-threaded versus single-threaded models to understand their performance implications. First, on the left, we have the various features we will use for our comparison. We begin by examining the thread model, a key differentiator in how they handle concurrent tasks. Next, we consider their performance characteristics, especially under conditions of high concurrency. We then compare how each architecture handles input-output operations and their efficiency. Finally, we'll look at the ideal use cases for each, highlighting where they excel. Now, let's explore the characteristics of a traditional server, such as Apache or PHP. Traditional servers typically create a new separate thread for every incoming client request. This multi-threaded approach often leads to slower performance when dealing with many concurrent connections. Their input-output operations are generally blocking, meaning they wait for tasks to complete. Traditional servers are often better suited for applications that are intensive on the CPU. Moving on, let's examine the distinct architecture of a Node.js server and its advantages. Node.js uses a single-threaded event loop to efficiently manage all incoming requests asynchronously. This design enables high performance and efficient handling of multiple requests simultaneously. Critically, its input-output operations are non-blocking, allowing it to process multiple tasks concurrently. JS is therefore ideal for real-time applications, APIs, and microservices requiring speed. Let us explore some essential Node.js core modules, which are built-in tools for backend operations. These modules provide a foundational set of built-in tools for performing various backend operations efficiently. The HTTP module is fundamental for creating web servers and handling various HTTP requests. This module is primarily used for creating HTTP servers and managing the flow of requests and responses. It plays a crucial role in handling incoming requests from clients and sending back appropriate responses. The FS module provides functionalities for interacting with the file system, enabling file management operations. You can use this module to perform various file system operations, such as reading from or writing to files. Specifically, it allows you to read content from files and write data into them programmatically. The path module offers utilities for working with file and directory paths, simplifying path manipulation. This module provides helpful utilities for constructing, normalizing, and resolving file paths efficiently. It is designed to manage and manipulate path segments effectively, ensuring consistent and correct file access. The Events module is central to Node.js's event-driven architecture, implementing event-driven programming patterns. This module enables you to work with events, creating event emitters and listeners for various actions. It is particularly useful for handling custom events within your application, making your code more modular. Now, let's walk through the process of installing Node.js and setting up a basic server. We will cover everything from the initial installation to getting a simple Node.js server up and running. Your first step is to install Node.js by downloading the appropriate installer from its official website. You can download and install Node.js directly from the official nodejs.org website. After installation, it's good practice to verify that both Node.js and npm are correctly installed on your system. You can verify the installation by running node version and npm version in your terminal. Next, create a file named server.js and add the code to set up a basic HTTP server. This code creates an HTTP server that listens on port 3000 and responds with a simple message. Finally, you can run your Node.js server by executing the nodeserver.js command in your terminal. To start your server, simply open your terminal in the project directory and type node server.js. Let's delve into the different phases of the Node.js event loop, a crucial concept for understanding its behavior. This will show us precisely how Node.js efficiently manages its asynchronous operations and callbacks. The first phase is called timers, which handles operations scheduled to run after a specific delay. Here, Node.js executes callbacks for set timeout and set interval functions, managing time-based tasks. Essentially, this phase is responsible for processing all time-based operations within the event loop. Next, we have the pending callbacks phase, which handles certain deferred system operations. It executes callbacks that were deferred from earlier input-output operations, ensuring their completion. This phase primarily ensures that completed system tasks are processed and managed appropriately. Following that is the poll phase, a critical part of how Node.js interacts with the system. During the poll phase, Node.js actively fetches any new input-output events that are ready. It then processes all input-output related callbacks, such as those from file system or network operations. After the poll phase, we enter the check phase, which has a specific responsibility. This phase is dedicated to executing all set immediate callbacks, running them after the polling. It consistently runs immediately after the poll phase, ensuring a specific order of execution. Finally, we arrive at the close callbacks phase, which handles the final stages of resource management. This phase is responsible for executing various cleanup tasks for any resources that are being closed. Here, callbacks associated with closed resources like file descriptors or database connections are processed. Let's explore the power of npm, the Node Package Manager, for managing dependencies and project workflow. npm is essential for efficiently managing all your project's dependencies and streamlining your development workflow. npm simplifies the management of project dependencies allowing you to easily include external libraries. It makes managing external libraries straightforward, ensuring your project has all the necessary components. You gain access to thousands of reusable packages published by the community, significantly speeding up development. NPM provides access to a vast ecosystem of reusable packages, helping you build applications faster. NPM simplifies version control for your libraries, ensuring consistent and predictable package versions across environments. This tool simplifies the management of different library versions, maintaining stability and compatibility within your project. NPM also helps automate various project build processes, from running tests to deploying your application. It allows you to automate repetitive tasks, making your project build processes more efficient and less prone to errors. Now, let's look at essential NPM commands and how to configure your project effectively. We'll cover installing, uninstalling packages, and defining custom scripts to streamline your development process. To begin, initializing a project with npm init creates a package.json file automatically. The package.json file is essential for managing your project's metadata and dependencies. This command initializes your project, creating a package.json file with default settings ready for package management. To install packages, use npm install for local dependencies or npm install g for global tools. You can install specific packages locally with npm install express or globally with npm install -g nodemon. This allows you to add necessary packages like Express to your project and global tools like nodemon. You can list installed packages using npm list and remove them with npm uninstall package name. The npm list command shows all installed dependencies, and npm uninstall express removes a specific package. These commands allow you to view your current dependencies and efficiently remove packages you no longer need. npm also allows you to run custom scripts defined within the script section of your package.json file. You can define custom commands in your package.json script section and execute them using npm run start. For example, you can define a start script in package.json to run your server with npm run start. We'll now dive into CoreExpress.js API development, focusing on step-by-step implementation. This section will guide you through implementing robust routes and middleware for your APIs. First, initialize your express.js project by creating a directory, navigating into it, and installing Express. You will create an Express API directory, initialize npm, and then install the Express framework. Next, create a basic Express server in a file named server.js2. Handle initial requests. This code sets up an Express application that responds to the root URL and listens on port 3000. Now, define RESTful routes for your create, read, update, and delete, or CRUD, operations. This example shows how to set up routes for users, handling GET and POST requests in a separate file. Implement middleware functions for tasks like JSON parsing and request logging to enhance API functionality. You can use express.json for parsing incoming JSON data and MorganDev for logging HTTP requests. Finally, add global error handling middleware to gracefully manage any unexpected errors that occur in your API. This middleware catches errors from any root or other middleware, sending a 500 status with the error message. To summarize our discussion, let's review the key takeaways for backend development with Node, JS, and Express.js. These are the essential concepts and practices you should remember for building effective backend applications. Node.js is a powerful JavaScript runtime environment specifically designed for scalable server-side development. Its event-driven, non-blocking IHO model makes Node.js an excellent choice for building real-time applications. npm, the Node package manager, is crucial for efficiently managing all project dependencies and external packages. Express.js simplifies the process of building REST full APIs, offering robust routing and middleware capabilities. Middleware functions enhance API functionality by adding features like logging, authentication, and request parsing. implementing effective error handling, and seamless database integration are crucial for creating stable and reliable APIs.